and the arts. My name is Dr. Erik Viirre, and I'm a physician at the University of California at San Diego. And I'm going to take the host privilege and talk about the frontiers of medicine for a minute. And I have to tell you that I've been a practicing physician for almost 30 years, and this last year, I am the most excited about the future of medicine that I have ever been. I have seen amazing advances. We talked about Stephen Hawking just a few minutes ago, and now we are looking at potential cures for ALS, the disease that has him in a wheelchair. And just a few months ago, I was talking to a leader of a large drug development company, and we were talking about the advances in the particular specialty that I am, which is neurology, and we were saying that we could envision the future where headaches would be cured, that headaches would go away. So just like polio, which was cured in the 20th century, you can see all of these incredibly devastating problems going away. And it's such an exciting time in medicine. And so it's a great privilege for me to have this panel, to have my colleagues where we're going to talk about technology and science and the arts and how the new things that are coming along are going to bring that forward for us. And so we'll start with my colleague and great friend, Dr. Cori Lathan, who is the CEO and co-founder of AnthroTronix, a great company here in the DC area that is looking at brain science and engineering and rehabilitation and bringing products to really help all kinds of people. So Cori, let's start with you and let's talk about the future of technology.
All right, thank you. Oh, do you want to introduce us all? I think they have all the...
Oh, okay. And so we'll, forgive me. So we have Dr. Alan Stofan, the former chief scientist of NASA, and we're going to be talking about the future of science and the exciting things that are coming in the 21st century that we are seeing right now. And my friend and colleague at the Arthur C. Clarke Center for Human Imagination, Sheldon Brown, who is our director there, and we're going to be talking about the future of the arts, again, which is just so exciting and amazing things happening. So with that, let's see if we can start with Cori and
Great,
technology.
thank you. And I'm going to stand because it keeps the energy level up, right? So I'm going to talk about human augmentation and the future of technology, and specifically the human-technology interaction. And there's a lot of fear around technology, robotics, artificial intelligence, but I'm basically a techno-optimist. So I like to, see what's the hope, what's the future of technology, and what can it bring us. So here's one picture of the future of robotics. I'm the surgery robot. I'll be doing your surgery this morning. Now, in some of us, that might instill a little trepidation, but I think as Erik was talking about the advances in medicine and robotics, I think that advances in robotics will help democratize medicine, will help us bring it to everyone, better care to everyone. What about artificial intelligence? At long last, true artificial intelligence. The computer says, the heck with this, let's go fishing. So I think that artificial intelligence can actually free us up to do the things that we do well as humans. Fishing is one of them, maybe, but also time for ourselves. Break us away from our computers. Wouldn't that be a great advance for artificial intelligence? All right, we don't have any of the kids in the room, so everyone knows who this is, right? Star Trek 7 of 9, Cyborg. Now, the cyborg of Star Trek painted a little bit of a scary picture, but I actually am looking forward to becoming a cyborg. In the next decade, I want better knees. I want bionic knees. I'm done with this knee. I want better than 20/20 vision. And I want that DARPA implant that's going to help my memory, keep my memory intact. So I think that the human technology interface of the future is actually what I'm most excited about. And so what I want to do, let me tell you a little bit about what I've been doing for the past 20 years on the human technology interface side. We've been working with kids with disabilities, with robotics to help kids with autism learn how to interact with their environment and build social skills so the robot becomes almost part of their identity so that they can express themselves. We've been working on instrumented gloves, which enable humans and people to achieve tasks they couldn't do. So for example, a soldier who's in a trench trying to send in a robot to look for hostages, or someone with a disability interact with a computer, that's through the instrumented glove. We've also worked with astronauts in space, trying to quantify what's happening to their brain as they're in space. How does it change, and how does that affect their performance? Can they still operate a robot? Can they still build the space station? So we've been working on the edge of human technology interaction, and I want to just go through 3 quick trends that then I'm sure we'll talk about in the discussion, but 3 trends that I think are really going to affect our relationship with technology. And those trends are human enhancement, social robotics, and the Internet of Things and People. So human enhancement, I've already told you my vision for human enhancement. And think of the human as an information processor. We take in sensory information, so there's room for enhancement. There's actually earbuds that filter out unwanted noise and actually enhance your hearing beyond what we normally consider human capability. And then we take in that information, we process it, and then we act on it. So on the action side, we have prosthetics already who, there's now a big question about the Paralympics. Are the Paralympic performances actually going to overtake Olympic performances because of the advances in prosthetic technology? On the processing side, looking toward the future, this is the Google contact lens where it actually can measure physiological response and diagnose diabetes and give that feedback to you so you can manage your diabetes better. And then I mentioned the DARPA implants. There's a program at DARPA where they're actually looking at, can we have neural chips that help us retain or even regain some of our memory processes? Social robots. Social robots have been around for a long time. This is Para, a seal that's been used for elderly and people with disabilities to actually help with social skills and comfort, and just, it's one of those things that it's been around for a long time. We all know kids who have stuffed animals. This one has a little bit of responsiveness, so it makes it more interactive. We have a lot of researchers. This is Justine Cassell's work from Carnegie Mellon, who's looking at avatars. How can we have computers that interact and help kids learn social skills, for example? And then many of us, who has an Alexa? Who's tried it out? Has anyone tried it out? Tried out the Alexa? I would argue that Alexa is a social robot. And there's all sorts of things that we can do with Alexa. And in fact, the next generation, what I would say the next generation of Alexa, is a group of robots that actually do what Alexa does, but also more, can move around and can interact with you and support your family. So I want to show you a quick little video. This is Jibo. Jibo just entered the market, and I have no relationship with Jibo other than that I bought one. But let me show you the vision for Jibo. It's a quick video.
Introducing Jibo, the world's first family robot. Say hi, Jibo.
Hi, Jibo.
Jibo helps everyone out throughout their day. He's the world's best cameraman. By intelligently tracking the action around him, he can independently take video and photos, so that you can put down your camera and be a part of the scene.
Jibo, take the picture.
He's a hands-free helper. You can talk to him, and he'll talk to you back, so you don't have to skip a beat.
Excuse me, Anne?
Yes, Jibo.
Melissa just sent a reminder that she's picking you up in half an hour to go grocery shopping.
Thanks, Jibo.
He's an entertainer and educator. Through interactive applications, Jibo can teach.
Let me in, or else I'll... And I'll blow your house in.
Hey, where'd you go? There you are.
He's the closest thing to a real-life teleportation device. He can turn and look at whoever you want with a simple tap of your finger.
Check out my turkey dinner, Mom.
I wish you wouldn't eat that.
Hey, they make turkey pizza? I want turkey pizza.
And he's a platform, so his skills keep expanding. He'll be able to connect to your home.
Welcome home, Erik.
Hey, buddy. Can you order some takeout for me?
Sure thing. Chinese, as usual?
You know me so well.
And even be a great wingman.
You have a voice message from Ashley. Want to hear it?
Absolutely.
Hey, call me when you're home.
Better make that takeout for 2, Jibo.
So Jibo can't do all that yet, but I think it's a great vision of where we're going with social robots and a realistic vision of how we're going to interact with robots and how robots will enhance our, not just individually, but then as a family unit, as a social unit. And in fact, the best thing that I think Jibo can do right now, which I didn't know, but my 14-year-old said, Jibo, can you twerk? And it can. It's hilarious. So you can probably find a YouTube video of Jibo twerking. Okay, and then finally, the Internet of Things and people. You may have heard about the Internet of Things, and we tend to think of machines connecting to machines. But what we sometimes forget is that behind those machines and behind the task that those machines are doing are people. And let me just give you a quick example of a not too distant future where your refrigerator has an alert, it's low on milk, so it sends a message to, maybe through Peapod over to Giant, and the robots at Giant load up the cart, they get your milk ready and they ship it to you, gets right to your fridge, and there you go, you're done. So that's a future of the Internet of Things. Well, what's behind that? Behind that is our people, right? And so probably maybe elderly, so their families can keep track of, are they eating? How much are they eating? How is their behavior changing? We know where they live. We know who they are. And so there's a lot of information back there that also can feel kind of scary, kind of a big brother-ish, but it's also really important information that can help us quantify healthy behavior and give us alerts if something changes. And I think social robots and Internet of Things and people is going to be very helpful as we age and is going to help us age in place and age gracefully and live longer. So I think with that, I want to just end by saying that it's up to us to shape the future. And so when we talk about robotics and artificial intelligence and the Internet of Things, we can paint a scary future, or we can say, you know what, this is the future that we hope for, and this is the future that we'll all create together. Thank you so much.
So the theme that I'd like to kind of pursue with this session this morning is how you personally feel excited about things. And Cori, you're such a wonderful friend and a wonderful mom, and you mentioned your children, and you've helped my family as well with your enthusiasm about the future, and that's what's so great. Maybe you can tell us a little bit about your initiatives on how you're bringing more people to be technologists and that enthusiasm because of what you think is important about that.
Well, I think this conference is obviously a great example of that, and I'm on the board of Kid Museum, which is a big makerspace in the Maryland area, and they're, I think, represented over at the Imaginarium. So I think it's really important for for kids to discover their own maker, their own inner maker, and their creativity and their passion for creating. And that might be it might be anything from building a robot to making jewelry. I mean, it's really, we all need to discover our inner maker, and I think that just encouraging kids to do that. There's a great documentary out there, and one of the things that they say is you shouldn't ask your kids, what did you do today? You should ask them, what did you make today? And so that really spoke to me, and I think that's what we need to ask kids.
And what about women as technology leaders? What are the things that you're thinking about there?
I think that it's an ongoing conversation, and we need to support each other to keep women in the STEM fields. I think there's a lot of women interested, and a lot of girls interested in STEM fields, and the harder thing is actually keeping them there. So I think showing them the potential and the excitement and what we can do, and mentoring. I think that's what we all do.
Well, you're such a wonderful role model for that, and we thank you so much for it.
Thank you, Erik.
So, Ellen, when we were talking on the phone, we were about getting ready for our session. We were talking about the excitement about science, and so perhaps leading into your discussion, give us a little bit about your personal feelings and excitement about what's coming up and what's happening.
Well, I think there's so much going on right now because, if you think what 60 years of space exploration has really brought us is this really profound understanding of our solar system, but also Earth's place in the solar system. And to me, I'm a planetary geologist, it always comes back to how can we use the information that we gain from studying our solar system, our galaxy, our universe, to always come back to our own planet and say, how did we get here? How did life evolve? How did our planet evolve? What is the fate of our planet, the fate of our solar system? And we learn that by looking outward and then looking inward.
So please tell us your story.
Sure. So what I'm going to be talking about today is one of the things that I'm actually the most excited about. I could talk about things that we've learned about our planet from looking outward, climate change. I'm going to talk about that a little later today. But this morning, I really wanted to focus on the search for life beyond Earth. And when you look at our planet in this view from the International Space Station, you really think about what is it that makes our planet so unique. We're a water planet, unique in our solar system in that sense, where we have over 70% of the surface of this planet covered by water. But of course, the other unique thing about our planet is that we have this amazing biosphere. And a huge abundance of living things. Now, obviously, all the planets formed about 4.5 billion years ago. By about 3.8, 3.9 billion years ago, life had evolved here on Earth. So very quickly, as soon as conditions stabilized. So when we look outward beyond Earth, looking for life beyond Earth, we really have to base everything on our one data point. And most people know when you base things on one data point, you're on a bit of shaky ground. But nevertheless, we only have one data point. So here we go. So when we look for life, we think that water is really important. So we're looking for planets that have some aspect of liquid water. But that's not the whole story. Obviously, you need organic molecules, but those have been delivered all over the universe. You find amino acids in interstellar clouds, in comets, in asteroids. So the building blocks of life are everywhere. So you're really looking for when were the conditions right. But if we look back, if we start looking outward, saying, where is Earth 2.0? Where is that wet blue planet where life could have evolved? You have to have a cautionary note. You look at all these planets up here. Those are actually all depictions of what the Earth has looked like at various points in time. So when you look out, for example, I'm going to come back to at the end, planets around other stars, you really start thinking about what are we looking for? Early in the Earth's history, up in the upper left there, the surface of Earth was actually covered in magma. We were a magma ocean planet, and frankly, that's the planet I'm looking for around another star, because as a geologist, that's the planet we actually know the least about. But at one point, Earth's surface was largely covered with green-blue algae, cyanobacteria. What about that planet? Those little cyanobacteria actually couldn't survive in an oxygen-dominated atmosphere, but they gave off oxygen. They're what produced most of the oxygen on Earth. They actually then made the planet largely uninhabitable for themselves. Does that sound familiar to anybody? We had a snowball Earth, but of course the one we have now is water Earth. As we go outward, looking for life beyond Earth, we really have a fundamental question. What are we looking for? So, our obviously, again, one data point, Earth. So what are we looking for when we go beyond Earth? So the scientific community has really been struggling. What instruments do we send? What are the questions we're asking? What are we looking for? And they've come up with this concept called the ladder of life. So in the bottom corner, just general indicators. Was the planet habitable? Was there liquid water? Do we think there were organic molecules on the surface? So those are kind of the most general indicators you can get to. Potential biomolecules. Those are things like amino acids. Do we find amino acids on the surface? Do we find more complex organic molecules? Then we get to functional molecules. Can we find evidence of DNA, RNA? Would life that evolves on another planet even have DNA and RNA? Then we look if it's living life, or what we call extant life. Does it exhibit metabolism? Does it grow? Does it reproduce? Does it exhibit Darwinian evolution? But you have to start in your measurements on another planet, way down there in the corner. Is it even habitable before you can get to the idea of complexity? Now, our main focus is on Mars. About 3.9 billion years ago, Mars looked more or less like the Earth. It had a lot of water on its surface. Over half of its surface was covered in water. And we know that because of rovers like our Curiosity rover. This is Mount Sharp behind me in the background. Curiosity has been slowly climbing Mount Sharp, going to each of those layers of rock and interrogating them and saying, what do those layers of rock tell us about what Mars was like at that point in its history? So Curiosity has told us this story of a wet Mars, of a Mars that was probably inhabitable. So all right, check. We've got that general indicators down in that lower left corner. Curiosity's been looking for organic molecules, but the problem is Mars doesn't have a magnetic field, so its surface is subjected to a lot of radiation. Radiation breaks up organic molecules. So what Curiosity has been finding are little shreds of organic molecules. So that's something, but just think if you'd taken a bunch of puzzle pieces and ripped them up into more puzzle pieces, and now you're trying to put together the puzzle. So we have a ways to go of understanding if there was ever life on Mars. And part of the answer to that problem is to send people like me, except not me, geologists, astrobiologists, chemists, engineers to the surface of Mars to search for life. Now, where else are we going to go? In our solar system, we look to the water worlds of the outer solar system. These are the moons of Jupiter and Saturn. Now, they don't have water on their surface. They have water in their subsurface. So this is an image cutaway of the moon Enceladus, which is one of the moons of Saturn. They have icy crusts, and below those icy crusts are actually liquid water oceans. Now, those oceans are liquid because it turns out as those little moons go around their giant planet, the giant planet is tugging on them just from the force of gravity. Pull, pull, pull. As the moon orbits, pull, 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 it melts the inside of that body, producing this subsurface liquid water ocean that has sat there for billions of years. So stable environment, water, likely organic molecules, shouldn't there be life? So right now, NASA has a mission planned to Europa, a moon of Jupiter that has one of these subsurface liquid water oceans. We've studied Enceladus, another one of these places with the Cassini spacecraft, and there are several missions proposed to NASA to go back and investigate, because in some of these places, both at Enceladus and Europa, some of that liquid water ocean is actually escaping or erupting out into space. So we can actually go and grab some of that subsurface liquid water ocean without having to melt down to it to actually analyze, is there something living beneath the surface? Now, the exciting part about what I just talked about, Mars, Enceladus, Europa, finding out, are we alone? Is there life? Okay, it's microbes. This isn't the most exciting thing in the world, but still, we are on the verge of discovering, did life evolve beyond Earth? I think we'll get strong indications of it within the next decade. Now, this is one of my favorite images. It's called the Hubble Ultra Deep Field image. And what you're looking at is about what the universe looked like about 800 million years after the Big Bang. Because when you look very deep into space, you're looking very, very deep into time because it takes that light so long to get to your telescope. So Hubble imaged this, and we were amazed at the complexity of that early universe. Each of these points of light in this image are not stars, they're galaxies. Billions of stars in each galaxy. Now, over the last about 4 years, we've had a telescope that we're about to retire called the Kepler Space Telescope. And over Kepler's about 4-year mission, it's looking at an area of the night sky that if it weren't snowing tonight and you went out and you put up your hand, you'd be covering up about the area of the sky of our galaxy that Kepler has been studying. In that very small area, it's discovered over 3,000 planet candidates. What that tells us is just about every star in the night sky has a planet around it. And Kepler had the ability not just to find Jupiter, Saturn, kind of gas giant-sized planets, it was finding Earth-sized planets, Neptune-sized planets. Those are the size between Earth and Neptune that we think have the ability to hold on to atmospheres, have water on their surface. We look for planets like this system. This is the TRAPPIST system, an artist's conception, obviously, that was discovered by a number of different telescopes, a 7-planet system. And there are at least 3 planets in this system that sit in what we call the habitable zone, that distance from a parent star where water could be stable on the surface. So within the next 20, 30, 40 years, we're going to find Earth 2.0. We're going to find that blue planet around another star. What an amazing time period for kids to be growing up in. You know, when I started out as a planetary scientist, we had 9 planets, then we went to 8. These kids have thousands of planets. It's going to change the way we view our own planet, our own solar system, and I would argue humanity. And when we talk about having to go to Mars to find evidence of past life, I show this image sometimes, and people say, why do you show that crummy, blurry image of the Earth-Moon system? This was actually taken by one of our spacecraft at Mars. And one of the kids at this conference might be the first person to actually see this view from Mars, because they're the generation that's going to go to Mars, discover evidence of past life, and what it means to humanity. Thank you.
So, Ellen, in America, we, by tradition and because we care, we say, thank you for your service to our service members, our military service members. But I gotta say, I think a lot of government employees are true believers as well. And of course, I think government scientists and probably government space scientists really have to be the true believers. If you have to spend your whole career just to get one experiment done, you really gotta have the belief inside. So thank you for your service in working for us to find these things out. And sort of along that theme, tell us about the NASA scientists and your sense of their excitement about what's going to be coming in the upcoming decades for space science.
Well, I think that's actually why NASA just this past week just got voted, I think, for the 6th year in a row as the best place to work in the government.
Well, there you go.
Because I think the people there are truly passionate. You heard some of my passion for this mission. You know, we're exploring, we're discovering. But even more importantly, I think for a lot of the people at NASA, the scientists, the engineers, is how do we turn that technology around to help people right here on this planet? The water purification system we use on the ISS, we take into disaster zones around the world. About 90-some% of baby formulas have a nutritional supplement that was actually developed for the astronauts up on the International Space Station. So when we develop technologies, when we push outward, you know, going to Mars, sending humans to Mars, that's a huge goal. And the agency scientists are so excited about it. But they know, how are we going to push technology in a way that we can turn around and benefit this planet?
So you're kind of lucky that you get to work there, too.
I did work there.
So Sheldon, whenever I go to your office at the Clarke Center, it's always really fun for me to see the things that you do. So you have these manual things in your office. You've done welding and table saws, and then we have this beautiful piece of art by your mentor, Harold Cohen, who was one of the first people to use computers as art. And so what I see in you is using tools to create new thinking. And most recently, your wonderful art assembly using virtual reality and neurotechnology, which is just fabulous. And so tell us a little bit about the exciting things that you see coming for art in the near future.
Well, great. And I guess I'll follow the lead and be on my feet here. Keep me awake for sure. Yeah, so I want to talk a little bit about art in relationship to the theme of imagination, but also what I think is a challenge for art in our time. And I have this quote up here to start, that art is distinctly a product of our imagination. In a way, we can see that art is it's kind of the research lab of imagination as a phenomenon in and of itself, both in the way art is created, but as just as important as what the role of art is in how it engages us. It's meant to stimulate and engage our imagination directly. And this has been the case of art over time. Art takes all of these aspects of disparate parts of human cognition and fuses them to create these kind of coherent views of our imaginations. And some of that can provide great insight into the reality that we're a part of. And sometimes maybe it kind of steers us into ways of thinking about reality that we end up having to go back and revisit and revise. And so at this time, there are some really very significant things going on that we've been hearing about. AI, the questions about the origins and future of life. And I think there's ways in which we need art to be an effective tool for us to think through these things. And so this quote from the science fiction author J.G. Ballard, what the writers of modern science fiction invent today, you and I will do tomorrow. And I think that comes true in a few different ways. And I specifically want to take a look at how art has prompted us to think about AI and how we might be able to engage art in a more effective dialogue to think through what we want from AI. So thinking about AI in a utopian framework that art helps us get to. And so we've had over the last few decades many representations of AI in art and culture. And I'd say through those representations, we tend to split these things into two camps. One is, AI as this kind of existential threat, a more dystopian view of it. And the other is AI as these kind of, cute, googly-eyed, subservient, assistants. And in both of these, we try to question both what the value of AI is to us, but then put an S on there and let's think about what the values of AI itself might be. So from these kind of more, simplistic kind of black and white representations, we of course had, really this kind of more, what I think is a more thoughtful, profound, and insightful way of thinking about AI and how AI is represented in both ways that are both explicit and implicit. And one aesthetic choice that I want to really point at with Clarke and Kubrick's engagement with AI in 2001 is the notion of the eye. And so the eye is one of these it's one of the features that a great deal of our perceptual cognition is highly attenuated with. The ways in which we engage with empathy to the other, to cement our social engagements, is really highly keyed to our very attenuated perceptions of the eye. We can tell when someone is looking at us. We can tell when they're looking 3 inches past us. We can tell by looking at the eye what their inner state is. The eye is the window to the soul. So in 2001, Kubrick puts 2 eyes in relationship to each other, the red eye of Hal and the blue eyes of Keir Delay. And after meeting Keir, I realized that the reason Keir was cast in this role is because his eyes they illuminate, they radiate blueness through this reflective mask that he's often wearing. And we get a window into Dave's soul that we don't get through Hal. And then the eye becomes the sight that is the indicator of Dave's ultimate transformation as he goes through the wormhole, and we start to see this kind of colored effect that is happening with his eye. So Kubrick isn't telling us at any point, look at the eye, but of course the eye is something that is deeply engaging for us as the audience in understanding what's at stake in the transformation of Dave and Hal and their relationship in this movie. So Hal gets to then go through and have this visual transformation of his experience, and Dave gets that transformation, but Hal isn't quite so lucky in what happens with him. But that eye, I think, also plays another kind of, it's even a pun that I think is being used here, because what we see in Hal is the embodiment of AI as an individual entity. And what we're seeing now is that kind of idea about AI is really not how AI is developing. So Hal not only is an insufficient representation of AI for us to have an effective relationship with, for the humans to have an effective relationship within the movie, but he becomes kind of almost a warning of, well, he is a warning of what not to do with AI. That AI can't be developed in isolation, or it goes crazy, basically, what happens to everybody in isolation. But we start to see that there are things about Hal that, he's inscrutable. When we look at Hal, we actually don't have any insight into what Hal is thinking. And so now we start to get these representations, these manifestations of AI systems within our life that we've started to see in one of the earlier presentations. And they seem to maybe not have learned a lot of lessons from watching 2001. They also are these kind of inscrutable objects. And they kind of follow the design ethos that has come from the evolution of the smartphone, which has taken all of these externalized things, all these that have these very specific physical manifestations, and collapsed them down into an increasingly refined monolithic rectangle. Now the thing about this is they were all functions that we have lots of cultural experience with, and so getting rid of the user interface to those specific things and remanifesting it within this device doesn't estrange us from them. Like, we still know what a telephone is, even though this now, looks nothing like the telephones we've had in the past, or a camera, or a map, or a computer. But AI is somewhat the opposite phenomena. We don't know what AI is. So as we start to create manifestations of it, we're drawing from a history that is more about minimalist art, which came out at the same time in the 60s, where we had kind of 2 types of artistic expressions that were dealing with ideas of transcendence and and essentialism. And we have maybe two representations here, minimalism on one side and psychedelia on the other side. And we're now in that situation where we're coming up with almost similar kind of tropes in how we think about AI, whether we have minimalist representations as we're seeing in these objects, or we start to look at other ways in which AI has representation. So the Deep Dream project that's come out of Google, for instance, which one starts to give us more insight into what AI actually is doing? Because on the one hand, with the minimalist things, we seem to think AI is this simple, monolithic phenomena, when in fact it's a collection of hundreds and thousands of different things that are distributed globally that interact in myriad complex ways. So is it more effective for us to see it as these kind of singular things that seem to, be insinuating themselves into our lives in ways that we really don't understand, or do we need to kind of see them in their complexity? So this is, I think, a significant issue because we all think that we all have hopes and fears about AI. And so how might we start to understand and engage what kind of future we want from an AI world, and how art and design might help to make certain manifestations of that? So I want to propose that we think about AI in a utopian context. And a utopian context is also a kind of, has a long history in art, philosophy, political science, where we start to try to create a synthesis of all aspects of the human condition that are underpinned by many kind of new propositions and sets of rules. And so what I think what we're needing is to think about AI in somewhat the same way we did during the kind of Enlightenment era, where we started to understand that we're reforming the notion of the individual and the social. And so what should the rights and responsibilities of the human, non-human, and everything in between be in this new regime? So, so there's just a few kind of notions that I want to just call out very quickly. Well, in fact, I guess before I do that what we're doing is, we're moving from this era of Moore's law possibly into this era of Murphy's law. Mm-hmm. And that's the thing we're worried about. And what we need from this condition is ways that we're probably going to have to address the problems that are mostly problems that we are causing. And so I would say instead of Moore's law to Murphy's law, let's of course move to Clarke's law, which to be the law that governs our next era, which the one that we've already heard about. The only way to discover the limits of the possible is to venture a little way past them into the impossible. And I think we do that by looking at how our new forms of art start to help us engage in ideas that stretch our own understanding of reality and our own imaginations. And it's a project that Erik was mentioning that we've got an actual small example with set up across the street where we're able to start to look at and use the brain directly as an interface into phenomena. And that phenomena can now start to undertake very complex actions that previously are not easy to understand and experience. So this is an artificial life environment that you interact and control with your brain. And it gives us a second data point for thinking about the origins of life. Underpinning a lot of what we're thinking about with AI, I think, is an idea of cognopositivism, that in order to escape the effects of the human condition, we have to actually increase the engagement of cognition across the human and the non-human. But we have a problem with that, even recognizing what the phenomena of cognition itself is. And so with AI, we both model cognition, what we think cognition is. As we do that, it starts to reframe what we actually think that phenomena comes from. But we're surrounded by cognition in all sorts of forms that we barely understand. And we often apply very anthropocentric notions of cognition to non-anthropocentric phenomena and probably miss 90% of cognition. So here's a little mashup of two cognitive systems, perhaps, that we mischaracterize. So this is a white blood cell chasing down invaders in the bloodstream. It seems to have a lot of agency taking place here. Things that might, in fact, be thought of as ways that are very relevant to cognition. But of course, a white blood cell doesn't have a neurological system. So what's happening here in relationship to cognition? And the soundtrack is dolphin vocalization. And so we try to map that to think about that as a kind of language. But perhaps we're missing the point of what it's doing because we're trying to put too much of a human framework on thinking and understanding that. So there's those kinds of things about cognition, but probably even getting a little less abstract, if we really want to radically increase cognition, probably the easiest thing, which has proven to be one of the most challenging things for humanity, is just improving the basics of justice and equality across the globe. And if there's one thing that AI might be able to help us with, this would be something that we should aim it at. How do we better understand, better take advantage, better improve just the basic conditions of justice and equality? And as we do that, we have to realize that we have to counter certain things, like neo-tribalism and the breakdown of our social institutions. So all of these things are somewhat being prompted by the developments of AI in this very kind of early stage, and recognizing that we have to ameliorate these things and actually directly kind of develop the technology to counter these trends. It also drastically affects our economics. And as we get through this stage, we'll see where we get to the other side. The science fiction writer Vernor Vinge has suggested that technology is developing so fast that humans of the future will think of us as having the cognitive abilities of goldfish. And so as this develops, it's this merger between us and AI that is likely to come about, both us as individuals, but maybe even before that, us and our social condition as one that's AI augmented. And as we go through that and come out the other side of it, I think it's going to be hard for us to even imagine who we were without that AI augmentation. Because what's I think going to take place is our notions of our own self are going to transform. That the idea of who we are now is very much comes out of the Enlightenment era definition of the individual and the social. And as we move through this AI transformation, we're going to find ourselves becoming, far more smeared and complex as individual and social creatures. We're going to become these kind of cyborgs. And these cyborgs aren't just going to be us as individuals, but us in a new kind of collective relationship to the world around us. And it's critical that our representations, our art and design of what this AI experience is, give us insight into that new condition, to give it tangibility and legibility. So I'll leave it there.
So we started with someone fessing up that she wants to become a cyborg, and someone who's telling us the implications of that. And what's out there in the universe may well look something like the AIs that we're looking for. So with that, we'll be able to take a few questions from the audience. I think we have a microphone, and if you have a question for one of our panel members, please go ahead.
It's a hot microphone.
Okay.
Okay. Tim.
And I was going to tie in two things. Actually, Cori made an interesting presentation about particularly this latest, I presume, Japanese-made robot. And what struck me was not only is it showing an eye in different formations, which gives us perhaps an ability to at least read what emotions it's trying to project to us, but it also has body motion, which is another way that we interact with other humans. So I just wanted, as opposed to HAL from 2001, I just wondered whether there was how would I want to put it? Is that a planned set of development or a foreseeable set of development in AI devices?
Yeah, and actually Jibo was developed by a woman from the MIT Media Lab, Cynthia Brazil, who's very well-versed in social robots and probably was one of the few people maybe who actually learned from the lessons from the eye and HAL. I mean, I was thinking that as you were speaking, that Jibo is incredibly expressive. And that's about the only thing about it that's engaging right now. Its technical capabilities are evolving, but in terms of its expressivity, in terms of its movement, in terms of the eye that is actually very expressive and not creepy, I made that connection as well. And I don't know if you had any thoughts.
Well, yeah, so I mean, there are definitely some interesting things going on there, that extending its actions into the physical realm so that it has, we're such physical creatures and we respond so much, even the way we understand and think is embodied, our cognition is embodied. I would say that there was an aspect of that where I was waiting for the music background to change and start to become foreboding and see it as a Stephen King kind of episode. So I haven't seen the robot in real life, but there is this, so there's this other phenomenon, the uncanny valley. Mm-hmm. And it's this very, well-studied thing in animation and robotics about when things, start to become human-like but not quite there, and are kind of, how we get creeped out by it. And I was looking at that and wondering, do I find that engaging? Do I find that creepy? Do I find that funny? Do I find that almost subversive? The cuteness might be subversive, that it might mask what's really going on by putting, like a googly eye on it, versus kind of having a really understanding what it's doing. But of course, it's such a complicated thing to try to have this understanding of what an AI is doing at any time. Mm-hmm. So it's this very rich, tricky, interesting design process that we'll be going through as a culture over the coming decades as this technology itself just so rapidly develops.
Okay, we have another question. Walter, can you stand up when you ask your question, please?
Thank you. This is fascinating and a bit scary, as you're also suggesting, or some of you are. In the video we saw of Stephen Hawking, he raised a couple of points that I hear you skirting around the edges on. One of them is his premonition, I'll call it, not that the human being may be at threat within 100 years, in part due to the superior intelligence and possibly malicious intelligence of AI. The second thing he said, though, is he believes that the future of humanity rests on our ability to find a home elsewhere. So since you all are looking into related and overlapping areas that see into those two premises of Hawking, I'd be interested in hearing your views.
Ellen, you want to start?
Sure, I could start. And I will say, to begin with, I've joked with the guy from DeepMinds, the people who developed the program that beat the guy in Go, that we need friendly HAL. When you have humans out at Mars, there's about a half-hour one-way light travel time. So that means when you say, Houston, we have a problem, an hour later you hear what? So So HAL becomes not just a science fiction thing, it becomes a necessity, especially after long duration space flight in a confined space. Humans are likely to actually be somewhat sluggish, slower reaction times. So AI becomes actually a necessity for us moving outward in the solar system. So the two are, to me, very tied together. We have to have AI really to move effectively beyond Earth. I'm probably an optimist. You know, obviously Elon Musk, Stephen Hawking have been very vocal about the fear of AI. I actually am more optimistic about it. But I also have a huge concern with people talking too much about humanity's ultimate destination is to leave this planet. It is, but you know, the sun is not a threat for several billion years. And we are facing right now into a complete planetary crisis with climate change that I don't feel like people are taking seriously enough. And I've had teachers come to me and say, well, kids in my class say we don't have to worry about climate change, we'll just move to Mars. That is not an option. There is no planet B. We need to focus on making sure that this planet is inhabitable before we really start moving humans, talking about the ultimate solution being moving off the planet, because this is the only planet we can get to that's actually habitable for now if we are careful. So that's probably my concern.
Yeah, I'll make two quick points on that. One is that I think that the conversation around the dangers of AI has been very productive, but I think we've hyped it up a little bit beyond where they started, which was really around how to shape the future of AI and set limits. It really started with Elon Musk and Stephen Hawking and Stuart Russell, a professor at Berkeley, who were really saying that we should not have autonomous weapons and that the US should be the proponent of an autonomous weapon ban. And I was a signatory of that as well, because at the time I was the chair of the Robotics and AI Council for the World Economic Forum. So I think the conversation is productive because, like I said in my talk, we have to shape the future. And so identifying where we don't want to go is really important. So I think that's one piece of it. And then the other piece of it is the quote by Vernon Vinge about humans of the future are going to look back and feel like we had cognition of a goldfish. That's where I think we're going. We forget when we talk about the pace of technology change that humans are changing too. Humans are dynamic. We have very different capabilities than our ancestors. We've lost some capabilities, probably some of our sensory capabilities, but we've gained capabilities as well. So I think humans are just as dynamic, if not more, than the pace of technology.
Yeah, and I guess I would say just it seems that it's much easier for us to solve the problems we've created on Earth rather than think we're going to reboot, a part of the population on a planet that we can't even get anywhere near to. And so those kinds, so not to say that we shouldn't be doing everything we can to explore and expand the reach of human knowledge. And send our little computationally embedded probes out to Proxima Centauri on light beams. Those are exciting, amazing things. But to even think that that's the only way that we're going to survive, I think, is misplacing our bets.
Okay, we have lots of questions, so I'll take them in the order that hands came up.
I'm Mike Nelson. I work for a cybersecurity firm, and we have a network that manages thousands, millions of websites. But I'm interested in talking about the Internet of Things, and particularly my concern, which is not about the robot overlords. It's about the human overlords who will use the Internet of Things and all the data they generate to really understand everything everyone does, monitor us all. Is that a vision that's inevitable? Or can you imagine a world where all of us interact with hundreds of devices each day, and yet somehow we have a shred of privacy left and governments or evil corporations can't track us?
Yeah, I don't know where to go with that one. I think if anyone wants to jump in, please feel free to save me, because I mean, it's hard to remain an optimist when you present it that way. I think we're redefining privacy. We want transparency. I mean, I think that's a big piece of it. We want transparency. And I think there is a big movement in AI to have, it has some catchy name, I can't remember what it is, but transparent AI, basically. And so we need to know what's happening in the background, and that's really important for lots of things. The cybersecurity, for medical decision making, for lots of things. So I think privacy will change for sure, and I think transparency is what we need to really try and achieve.
So what's the what?
Yeah, and the other thing I find really interesting, because I'm with you, and I actually think it's really frightening, but I look at I have 3 kids, they're all in their 20s. They have a very different view of privacy than I do. To me, it's, I don't want anybody knowing anything about what I do, and and I'm more, if you will, paranoid about it. My kids are like, yeah, everybody knows everything. Websites know everything. That's the way the world is. Let's move on. They just don't have the same kind of concerns about it, which I think is, I'm not saying that's bad or good. I think it's really interesting for where this is going to go in the future, when maybe that millennial generation and younger just have a fundamentally different concept of privacy than maybe those of us who are slightly older.
Yeah, I think it's this transformation of the notion of the individual and the social, and the ways in which they interact with each other. And as you say, there's people who've kind of come up with that as a natural condition and don't find it alien at all. I think the challenge for us going forward is to actually be thoughtful about how do we legislate this? How do we promote the social commons in this kind of environment? And we're struggling with that right now. So it's, and in part too, because, we sort of predict that the technology is going to do this, but then it kind of does this, and so, how nimble can we be? How comprehensive can our thinking about this end up being?
Well, I like your formulation that artificial intelligence will make us think about our humanity. And in this realm of the way that the younger generations are looking at themselves and social interactions goes with this idea, or goes up against this idea that Clarke brought to us, which is what happens when we see evidence of artificial intelligence out there in the universe. His construct is, it'll be the seminal event of humanity, right? We're intelligent, oh my gosh, there's intelligence at Proxima Centauri or somewhere out there. They send a laser beam message to us, and oh my gosh, that's going to change humanity. So it may be the millennials is like, cool. We're good with that. We're good with everybody. So the idea was that life and artificial intelligence would bring humanity together, and maybe we're really doing that with the technology right now. So we can be a little bit optimistic about it.
Okay, we have at least 2 more.
Hi, Jennifer Lakey. My son's across the street, imagining all the future opportunities he could play in science. But I work on energy issues, and I work in some of the most difficult areas of the world to bring electricity or energy and improve people's lives. And I'm curious about the democratization concept and the idea of technology empowering people. And right now, that access and the ability to be part of this conversation is so limited in so many places. And I'm wondering where and how we see the technology opportunities reaching into areas of Africa or India that are going to need very quickly to be brought into this conversation, because the gulf between their existence and our vision of where we're heading is so huge and only growing. And that could mean that power and institutional capacity lags dramatically and continues to grow, a gulf between us and them in the worlds where we find these technologies are not available. Do you have any comments or recommendations on how to begin to bridge that divide and bring in the sort of democratization of this technology to other people and other cultures?
Well, I got to leap in on that one because it sounds like tricorders to me, right? So Cori and I were recently greatly privileged to work on a program for the X Prize called the Qualcomm Tricorder X Prize, which was to bring health technology into a mobile package. And that's the exciting thing to me about democratization of technology. The US energy footprint is actually going down because we're getting much more efficient. We're actually not radiating all kinds of radio waves out and wasting them into space. We're being much more careful about energy management. Our tools are getting better all the time. And so the beauty of that is that we can transport that with our AIs, including our medical AIs, and drop that into a village in Africa and make a difference there. And so I think that's really going to be exciting, that a person in any place in the world will be able to talk to a device, it'll translate their language, it'll call out to a medical database and grab that information back and bring it back and help them. And so that was just the inspiration that we had working on this mobile health technology, and we could see the future of those as they were being built. So I'm keeping my fingers crossed that small, efficient energy packages combined with AI and computer science will actually really be a democratizing tool. So cheering for that one.
You know, I would say I think this is a huge concern. There's positive aspects. CubeSats, for example, you have countries in Africa, Philippines, countries from all over the world who are now building CubeSats. You have high schools, even elementary schools, building CubeSats. So you have what used to be a satellite, you know, oh my gosh, that's something for a big company or a government. And that is being democratized because the technology is getting smaller. It's, you know, easier access to space. The other positive thing I see, there's a NASA USAID program called Viirre, where we work with countries around the world that are the most vulnerable to the effects of climate change to say, how can we bring you Earth observation data to help with water shortages, challenges to agriculture, challenges with sea level rise. So there's bits and pieces, but I think there's a long way to go, especially in terms of climate change, because the people around the world who are most vulnerable to the effects of climate change have the least ability to deal with it. There's ways technology can help with that.
Okay, here's another.
I'd like to encourage you to explore a little further the impact of what you're working on how human beings will relate to each other in the future. In other words, when we even consider the possibility of having an alternative to a conversation with a spouse or a sibling or a child, we can interact with an artificial intelligence. We could at least begin to imagine interacting with a species beyond Earth or an artistic representation of a human being. Will that drive us away from or closer to our next door neighbor? My children now text and I can't get them on the telephone. And the notion that I have something to interact with that might be more malleable than a human being, will it bring us closer or will it drive us apart?
Well, if you look at what's happening right now, it's driving us apart. I mean, it's already doing that. The technology is already doing that. You saw that in the last election, certainly, where information through the internet was being manipulated on multiple levels. And increasingly, we live inside bubbles of information, partially that we create, but partially that are being manipulated around us. And I really do worry about that. And I agree with you. I think I see people becoming less humanly interactive. Okay, there's benefits to AI, certainly when you look at the elderly in isolation. So there are ways that I think you can say this has some positive aspects, but that's an area where I think that people who are developing these technologies, providing these technologies, really need to think about what are we doing to human interaction and human empathy by driving people apart rather than trying to drive them together.
Well, and I mean, we're in the neonatal stage of this kind of technology condition that is come about after the creation of the internet. And so if, we think back to like kind of Clarke's ideas around global satellite communication and what that would do to collapse and bring the world together. You know, so there was a very kind of utopian vision behind that. There was a lot of utopian visions behind what the internet could do and can do. But as its capabilities start to become, you know, more articulated, exploiting them for short-term self-interest is an aspect of the human to try to do. And so then the other aspect of the human is to recognize that we can actually counter that. You know, we can do things in legislation, in social organization that actually take our technologies and our methods and put them into a structure that facilitates what we think is the social commons and the social good. And so I think what's happened is we've seen this disconnect between our institutions between our social institutions and between these technological methods. The social institutions are too slow to react. They're too bound up in all of their, you know, complicated processes and procedures. So I think we are coming to the point where this technological condition is going to cause us to really think through what our, you know, how we should articulate the social commons.
I also think, you know, on a more positive note, redefining the concept of privacy. I think we're going to see the same thing in social interaction. You know, the Gen Zs who are all digital natives, they're going to be more connected than any of us ever were. And I think that we can facilitate the development of empathy through that connectivity. I mean, our kids know about global issues and global problems way more than we did when we were young. And so, you know, I think it's going to be hard for us to understand it since we're not digital natives, but I think digital natives are going to be more connected, more empathetic, and probably more equipped to solve some of our global problems. And that's, you know, I think how we can help shape that generation.
Okay, we have several questions. You're next. Thanks, Jeff.
Hi. Oh, okay. Speaking on the social side, one other trend that's been happening is a definite polarization in society of a bigger divide between the rich and poor, between the privileged and the unprivileged. And we watch, like right now, all references to climate change on the EPA site being taken off. And right now, the kind of dominant kind of thinking on the economic system is one that supports that kind of polarization, the inequality. Clearly, we need a social imaginary that goes beyond the tribalism and the individualism and the consumerism to one where our own sense of self identifies with the planet and with the species and that kind of thing. But there's all these kind of political and economic forces that really fight back against it. I see we're still in these culture wars, and I think a lot of the battles, a lot of what we're talking about, that to be successful, we have to win those culture wars in the battle of ideas and the framing of how we look at words like freedom. And there's a war against science right now. I'm wondering, you know, some of your thoughts about how we operate in these culture wars with the battle of ideas and in moving towards this other social imaginary and towards towards a kind of a sustainable society, you know, in terms of our resources and how we're dealing with things, and that gets us through this era of past the fossil fuel economy and towards one that will allow us to survive another 1,000 years.
Well, if we take the 1,000-year perspective, and we recently had Andy Weir, the author of The Martian, and his most recent book called Artemis, at the Clarke Center in San Diego, and I had the privilege of hosting him there. And his view is the Clarkean one, and so, which is that he has an optimistic view of humanity. And so while I well understand and see your concern about what's happening in our immediate period of time, his argument is, if you look back century by century, every aspect of human life improves over the 100-year interval. So we see dips and things that go on, and we have this terrible concern about what we're doing, all these millions and trillions of little fires that we light every day when you turn your engine on, are heating up our planet. But at the same time, humanity has really worked together. And so this is, lots of people have articulated this idea that we are improving, and I ultimately ascribe to that view as well. So I worry that social forces right now are being diverted for nefarious purposes, but I believe that our better angels will prevail. But that's a belief. Clarke said, intelligence is not shown so far to be a survival factor. So we'll find out. But we've seen so many things, and I think the message of our panel right now is that we see this optimism, that we see it for technology and science and for art, and as I said, my own discipline in medicine, it's stunning. It is stunning what we see coming. And so, for example, the challenge in medicine right now are very, very expensive medicines, but that they cure diseases. And so that challenge of cost versus the dramatic benefit that we experience. But we've had this history before. The first vaccine cost, equivalent of hundreds of millions of dollars in effort to test, but ultimately was the march of dimes that produced doses of polio vaccine that cured polio. The picture I like in medicine is the room full of iron lungs, of people living because of polio in a machine. Those things are gone. We cured it. Polio is gone. And Clarke was one of the examples of that. And so this leverage of exponential power, our buddy Peter Diamandis, a previous Clarke Foundation Lifetime Achievement Award winner, putting the advertisement out there, tells us about the exponential possibilities. And so I think we have to grasp that and send that message that we'll do better.
But I also think, though, that there is a question about the imagination in what you asked. And the philosopher Frederick Jameson quipped, it's easier for us to imagine the end of humanity than to imagine the end of capitalism, right? And so I would then kind of turn it back to maybe one of the,
unless you watch Star Trek,
one of the roles of the arts is to actually think through some of the things that you've brought up and to imagine what those futures could be like that ameliorate and address the problems that you've raised. And I would say some of our great works of science fiction are doing that right now. We're going to honor Kim Stanley Robinson with a Clarke Award today, and I would point you to some of his work, like the Red Mars, the Mars trilogy, which kind of ties up a lot of what we've been talking about today. It, looks at how we might colonize Mars in a post-capitalist scenario. And it's all Mars standing in as a kind of doppelganger for Earth and how we might address the problems of global climate change here. But there are aspects of our arts that need to stretch, embrace, and address the problems that you're bringing up for us to be able to have a kind of literacy of how those ideas might come back into our social reality.
How are we doing on time? We have 10 minutes, Erik. Okay. few more questions.
Just want to follow up in regards to some of the things you talked about. Growing up, a lot of us on the stage as well as in the audience didn't have too much AI, but we did have parents that said, turn off the idiot box, go outside, play with your friends, go to the library, go do something with your time. And some of the time we spent was with the arcades, which was probably not a good use of time, but it was art and it was experience and it was enlightening. What would be, I guess, some ideas that you might have if you were asked to work on a Lexus 5.0 or Jibo 6.5 or whatever? What are the things that, if that was your time, you would want your children to see or not see? And what would you say AI is good in this area, but not necessarily in these areas for their development?
Well, it's funny you mentioned that. Again, kind of thinking about Clarke. I think about the librarian who bought the books that I read as a child. So my community library, I grew up in a small town north of Toronto, and the library was my friend. I was one of those kids who took 10 library books out at a time, and I was reading them all simultaneously. And of course, there was plenty of good old-fashioned science fiction there, and I read Clarke and Asimov and Heinlein and anything I could get my hands on. And somebody put those books on those shelves. They thought about them, they bought them, and they put them out in the community. So I hope that we have the equivalent of those libraries for our kids. And I feel that. I have a 7-year-old and a 19-year-old, and they get to see pretty cool stuff. I wish I had some of those things when I was a kid. I worry that they spend a little too much time on the boxes and not enough time outside. But there's amazing things that we see, just sort of popular science programs, and my kids eat it up. And the beautiful part is I take them to a bookstore and they'll pull a book off the shelf and sit down and read it and take it home because they want it. So I think that desire for those worlds is still out there, even against the media that is so compelling. Like Sheldon and Cori and so many people at NASA, virtual reality is just an exciting thing. I've worked on it myself, but a good story is a good thing as well. So the physical activity is important. Our sedentary society is an issue, and hopefully we'll create new games and new engagements and meet people of different cultures that'll take us outside as well. Anybody else on that one?
Well, I would answer it a little bit differently in terms of, Jibo 6.0, but definitely building on what you said. I think the next phase of interactive technology needs to focus on shared experiences. And I think we have some real potential there. You're going to see, I assume you're using EEG headset, and if you go over to the Imaginarium, EEG headsets measuring brain function has become commoditized. You can buy a headset that gives you biofeedback for meditation. So that type of technology, measuring your brain function, has become commoditized. The science is there. There's great research out of Princeton that shows that when two people are talking to each other, that their brainwaves actually start to synchronize. And in fact, the listener's brainwaves start to precede the person who's talking. And there's a lot of research about how those shared experiences facilitate the literally being on the same wavelength. And so if you can actually bring people to the point where they can have a shared experience, I think it will do a lot to bridge these huge gaps that we're seeing right now just in our politics, in our population. I mean, that there's a lack of shared experiences. And so I'm really excited about, technology 6.0, 10.0, but it's going to come really fast. And the focus will be on shared experiences.
Because I really do worry about it. I mean, I've been in restaurants recently where there's two kids and two parents, and the parents are on their phones, and the two kids are watching shows on their iPads. And you're like, a meal is supposed to be a shared human experience. And I really, at some point, it's obviously parental responsibility, human responsibility to say, put down the device and remember how to do human interaction. And I'm worried we get away from that way too often. And I was the mean mom who I want Jibo 6.0 to say, shut me off and go outside. That's what I would program it to do.
And I worry about, I have two kids. I worry that they haven't been bored enough, in their lives, and I worry that stuff works far too well for them, and when when they're having these kind of challenges with technology, it's because they haven't learned how to level up or something, as opposed to thinking that they have more agency in kind of creating their experiential domain. And so when I think about what the next evolution of these robotic systems might be, these AI systems, how do they become these kind of collaborative extensions of them that they have responsibility for, that they teach, that they nurture, that has more bidirectionality, rather than them being kind of consumers, operators, and kind of target audiences of. And so I would hope to bring in these less smoothed corners of human experience and bring some more kind of sharp edges and cliffs back into the experience of childhood.
So we have time for one last question.
Maybe two, Erik.
Maybe two? Okay. That's two quick ones.
Yeah, my name's Angie Edwards, and I'm a librarian in a senior school in the UK. And I'm absolutely fascinated by what you said about how the children's perception of privacy has changed very much compared with our own. And as an educator, I have a real problem explaining to them how when I help them try and research information, they can't, their heads are open access, but the information they require is not all open access. So they're never in a full position to make the great leaps in imagination that they want to do because they don't have all the facts. And it's all down to people being very precious about their ideas, hiding behind their firewalls, monetizing their leaps and increments in what they're producing. And how do you see this next generation who are open access in their heads getting hold of that information for free so that they can unleash what we're trying to inspire?
Well, that's sort of the open source movement, right? Where code wants to be free, kind of thing. And that's the amazing thing about computation being free. I mean, essentially, cloud services they just give it to you, which is kind of a stunning thing. So there's certainly the walled gardens, but we transcend walls. The interesting thing will be the people who can't pay the price that we pay for our fancy electronics, the ones who will scrabble for it. What are they going to build, and what will we see there? Anybody?
Yeah, I think it's a critical issue because if you look, for example, at like NASA Earth observation data, all those data are freely available over the web. So everyone has access to NASA data with the idea that value can be produced downstream. But I think when you look at things like, say, the challenge of climate change, who has access to what information to make decisions? And that becomes then increasingly important, especially for countries that maybe don't have access to that kind of data. How can they turn that data into information to help them become more resilient to climate change? So I think there are huge issues, and I think that educators have a huge challenge with kids right now into saying, how do you become, good consumers of information? How do you become a good user of data? How do you know what's real data and what's false data? And then how do you differentiate between data that's intellectual property and data that's not? So, because these kids don't need to memorize the, 21st presidents of the United States, they need to figure out how they're going to deal with this increasingly technological world. It's a whole different way I think they need to really learn to cope with information than my generation did.
One last question.
Okay, one last question to take us out.
Hi, everyone. Dava Newman. Great to be here. Great session. Thanks. So I imagine a future in science and technology and arts where we reach parity. So what about the women and people of color along with the men? And Dr. Stofan told me that. We just talk about normalizing. We had the opportunity to be at NASA together. We've been at this a long time. We talk about STEM. I talk about STEAM. So I want to get some quick comments, maybe from the men first, on how are we going to do, serious movement in equity and parity and make sure that everyone's at the table.
Well, I hope that the equity and parity comes from the technology itself. Just from the previous comment that it's access to all, and that knowledge wants to be free, but it'll become on the recognition of those of us who've had such privilege to be able to give that back. Our institution, the University of California, really works hard at that. And I certainly know that our federal government institutions work hard at them as well. I think it has to be a part of policy and recognition. So it's a message that has to go on. Sheldon, what do you think about?
Well, I think one of the things I was trying to point out in these kind of utopian schemes that we sometimes probably think, a little too hopefully, that, just to contradict you a little bit, Erik, that technology will solve all our problems. And I think as we've seen with things like, gender bias, racism, economic disparity, that these things have such deep embedded roots that it's astonishing that we, sometimes think we've made great progress, and then we're astonished by how little progress we have actually made. So continuing to keep, a bright light shown on these issues, I think, is really critical. And I think it's one of the things that I would, that again, I look to our arts to do, to shine the lights into those corners that we, aren't always looking into, and revealing some of the, the major deficiencies that our social structures still currently have. Even when we kind of think that, ideas that you're putting out there, yes, these are our ideals and we should be doing this, and we can all say that, but why aren't we doing this? Where have we fallen down in this process? Where are, the things that are deeply institutionalized in our society still needing to be addressed? So it's we have a lot of work to do.
Yeah, I'd echo that. And Dave and I worked a lot on this at NASA. But if you look around this room right now, if you look at science, technology, engineering, math, computer science, we are failing. We are failing at normalizing the populations who are working on these tough challenges. Why does it matter? Because of all the things we've been talking about today. We're leaving talent behind when we don't bring everybody along with us. And we have a myth that we live in a meritocracy, and we don't. And if you don't believe that, go look at the research, and boy, are there piles of it. For example, a recent study just came out about women of color in the sciences. They face both racism and sexism, so they're in a double jeopardy in terms of how they're treated, how they're supported. So, big surprise, they leave in much larger numbers because they're not supported. The research is there to show why the numbers aren't there, and that research allows us a path to how to fix things and move forward. So, but it takes a conscious recognition. We don't live in a meritocracy. Don't pretend that we do. The way our society looks is because of lots of little decisions along the road, but we can fix it, and we need to work on it harder because we're still failing.
And I guess the 2 points I would make, one is that, Dave, I'll borrow your term, I'm steamed. So, add the A of arts, but also add the D for design, but also I'm steamed. I'm mad that that we're still having this conversation. I mean, we've had this conversation for decades. So I am steamed, although I do think being steamed is a way out as well, because we're being more inclusive. I talked earlier about the maker movement. And the other thing that gives me hope is, again, I mean, I hate to put everything on our kids, but I mean, Gen Z is pretty amazing. I mean, they're redefining privacy, they're redefining social interaction, they're also redefining gender. I mean, if anyone saw National Geographic's issue on, you know, basically gender creativity and gender non-binary, I mean, we have kids who, you know, at my kids' schools who don't go by he or she, they go by they. I have a transgender child. I have, you know, a child who doesn't believe in labels, and I tell her there's a label for that. So, you know, I mean, so it's if we can redefine something as basic as gender identity, which is so ingrained in our culture, which that generation is doing, that gives me huge hope.
Well, with that optimistic note, that our future generations will carry us forward with unleashing imagination. I'd like to say thank you so much to Cori, Ellen, and Sheldon for this fantastic discussion, and we'll look forward to having more discussions out in the hall with you from now on.
Thank you, Eric.
Thank you so much. I just want to also thank you because you've done such an excellent job of what we hoped you'd also do, which is